Professor Moleff here, and I get the opportunity today of going with you over our assignment number 7, correlation and simple regression. And what we're going to do today is we're going to do a scatter plot, which you can see here on the screen, different scatter plots. We're also going to do correlation. We're going to use the scatter plot to draw a line. You can see a line here and look at the correlation between the points. That will also give us a regression analysis, and then we will run regression, a single variable regression, then a multiple variable regression. We'll talk about some outliers and do some forecasting or predictive analysis. So pretty fun assignment. I think this is one of the best uses of Excel, especially in prediction. Again, one of the reasons that we use data is to make great decisions, and one of those great decisions that we're trying to make is how to forecast. So before getting into this assignment, I would ask that you please watch the video in the module prior to this. Also do the reading, which will give you some good information. That's some very good information on correlation and how it works and the use of these scatter plots. So I'm not going to go into big detail on that. I want you to watch the video. The other thing before getting into this assignment, you need to make sure that you have downloaded and installed the data analysis tools, and that's also in the module. You can look at that, but here in our tool pack, you can go to this tab down here, and this shows you how to do it on a PC or Mac and install the tool pack. You'll know you've done it right when you go into data, and on the far right you'll have the tool pack, and for a Mac it shows data analysis, and you can see that we have regression right here as one of those factors. And that's how you know you've done it right. But before you get started, make sure that you have downloaded and installed the data analysis tool pack if absent. And we do have instructions for PC, Mac, and also for Microsoft 365. So please make sure you do that. We have several tabs down here. We have correlation, spurious correlation, and I hate that my PC always does this, or my Mac, it hides my pictures and I have to go click on my pictures. But we have correlation information. This is cute, talk about spurious correlations, which was in the video. We have the tool pack. We talk about variables in regression here. Regression is a linear regression. We're going to go through this a little bit more in the assignment. But the data set we're using is Ann Arbor data rentals, Ann Arbor, Michigan, rentals. And we want to thank Dr. Benson, who went to the University of Michigan, who got us this information from rent analysis there in Ann Arbor. And all of this is within 6 square blocks of the University of Michigan. It's a little old, rent's gone up, but the data file is a great data file for us to learn. And so we're going to do these 5 things that we have here on our to-do list. We're going to create a scatter plot, and inside that scatter plot we're going to add a trend line, and we're going to figure out some information from that trend line and compare it to a correlation analysis. Then we're going to run a regression on a single point variable, which is square footage, and we'll compare that to the trend line and our correlation. Then we're going to run a multiple regression analysis, meaning we're going to have multiple data points. So the first thing I want to do over here is we're going to build our scatter plot. So let's take and move these over to the right a little bit. So I'm going to grab these and take them over here to the right, just so that we have room. Now, one of the things that we did here is you notice that the A column and the E column are the same. And what we did is we had to move our rent column over here to the right of our square footage, because when we're doing a scatter plot, we have our X and our Y analysis. and X is on the left and Y is on the right. So we need to make sure that we had done that correctly. So what we're going to do right now is we can just highlight this here, and what we want to do is you can just use the shift and then the right arrow, so shift and right, and then while you're holding it, shift command down, so we can highlight those right there. And we will go over into insert, and in the middle we have recommended plots. We can choose that, we can go down and find it, or we have this scatter plot. We can just click on our scatter plot, and now we have our scatter plot right here. So let me do that again, and you'll see how I did the shortcuts. So over here I highlighted in D1, I highlighted square foot, used the shift button in my arrows, so shift over, and so I'm highlighting D in E1, and then shift command or shift control down, and it highlights the both columns, and then insert, and I chose scatter plot. And so here is our scatter plot. I'm going to bring it right here. And like we've done in the past, we're going to format this a little bit. We're going to format the chart. The first thing I'm going to do is click on the title, and we're going to change the title. This is the correlation between square footage and monthly rent. And what I talked about before is make sure you're good and descriptive in the title, so that when people look at it later on, they can see what it's about. And then we can format it. Easiest way to format is you can click out of it and then click on it, and you see that that's highlighted, and you can go to format, which gives you an option up there, and you can also go into home. I like going into home because I'm so used to that, and I can hit the B for bold, and we can increase our size. Matter of fact, I want to increase the size so you guys can see what I'm doing a little bit better. So I'm going to increase this size. So there's our correlation, and then between square footage and monthly rent. The next thing I want to do is I want to add both my horizontal, which is the horizon is on the bottom, my vertical is going up, my axes. So over here, if I'm out of this, just click anywhere on your chart, and you see here at the top you have chart design and format that comes up. If I click off, you see that it goes away. So when you're working on something, what you can do is when you click on that, it shows me where my information is coming from, and then also I have chart design. So I'll click on chart design, and on the left there we have add chart element. I'll do the click down, and axes titles. I want to do my primary horizontal, so it comes up right there, you see here at the bottom, and I'm going to change that because this is our square footage down here at the bottom, and we can just change that to square footage. And I got to be able to spell footage correctly, so square footage. I can click out and format that too. I can bold it, give it a little bit bigger, maybe a 12-point font so it's easier to see, and then click anywhere again on my chart. There, my graph, and now I want to go into chart design again, and I'm going to add chart element, and we did the horizontal. Now I'm going to do the vertical, and sometimes it's difficult, to type in there. So once I put my cursor in there, I can go up here to my function bar up there, and I'm going to type in, this is my monthly rent. Monthly rent, and hit enter, and you see that it changed down here on my horizontal or my vertical axes. And then I'm just going to make that the same size as my other one. So bold it in 12, and so we've got this right here. The other thing that I want to do is you can change the colors and different things like that. just for better display, but this is what we wanted to do for now. The next thing that I want to do is get rid of these lines. So I have all these lines in here, and it's sometimes hard to read. So if you see, if I click on the horizontal lines, I have my blue dots between the horizontal. And if I do my vertical lines, I have my dots between the vertical. And you might be able to hear my dog in the background who can see me and wants to play. But what we want to do is get rid of these vertical lines. So if I click on them, and I have the blue dots that are my running vertical from each of these lines, and then just hit the delete button, delete, and it gets rid of that. So it's much easier to see. And then the last thing that I would do on formatting on this is if I click anywhere and click on my chart, I go on chart design, and then format, and then over here next to shape fills and outline fill, and I want a black outline. Now you got to be careful, because I have two charts inside this. I have this chart right here, which is all my dots and stuff. You can format that separately than the entire chart. So if you click on the inside and you do the format and you do the outline, you see that you get an outline now on the inside of your chart instead of just the outline. And I don't want that, so I'm going to click this back. I'm going to go back and get rid of that, and you'll see now when I come out of there, my chart has a black border around it and not the inside of my chart. So one of the great things about Excel is, now that I've done this, is I can easily add a trend line. And so how you add the trend line is I can click on any of these blue dots, and you see that these blue dots come up. I can click on any of the blue dots, and then I right click, and right here it says add trend line. So you can add your data labels in that, but we just want to add a trend line. And when you add the trend line, what happens is you have this format trend line come up. So some of the things that I like to do on it is I'll go over here in this fill button, and I like mine being a solid line. Okay, and my dash type, I don't want it to dash, and then I can even choose the color, and I would like this to be the blue, same as the other. And so now I have this trend line. The other unique thing about this is on this graph looking thing over here, what we have is we have display equation on chart and display R square. Now mine's set up that I can see this very easily. If yours isn't set up, you may have to scroll down, but you can hit display equation on the chart and display R square value on chart. So if you go ahead and click on that, both of those, you'll see that this equation comes up. And I'm just going to make this a little bit bigger. I'm going to format that. I'm going to increase my font to like a 12 or a 14 so you can see it easier. I'm going to bold it, and then I will move it right here in my chart, and we'll keep it in there for a minute. So what this trend line is giving us right here, this y equals 0.552x plus 512.98, and then this r squared that we see right there, that's giving us a lot of information. This is our y equals mx plus b line that we know in mathematics, or sometimes in business is y equals ax plus b, which doesn't matter in there. It's our trend line right here. So our variables in regression, so our linear equation, y equals mx plus b, this is the linear equation for math. We see this y equals bx plus a linear equation in business. I don't know why it has to be different, because it's the same equation and it means the same thing. But I like talking about y equals mx plus b. I have this y equals bx plus a here, so that we can understand y is the value we're trying to forecast. So if we come over here, we're trying to forecast what our rent is. Okay? And so y is what we're trying to forecast. The mx or bx, the b is the slope of the line. It's how much of x is shown or is part of the equation, and then the x is the value, the independent value, so it's what can change, and the a represents the intercept or the fixed cost. It's also if the m on the mx is 0, okay, or the x is 0, what would the intercept be? Or it's also fixed cost. Now, what's unique about this is we can have multiple variables. Now, in a linear equation like that, we can't. But when we do regression, we can have multiple variables. We can have our y equals mx plus m1x1 plus m2x2 plus b as our equation. So we can have multiple variables that affect that. Now, we can't in Excel show that in a scatter plot or in a linear equation single line in Excel with the scatter plot. Okay? But what we're going to do right now is we've added this trend line, and again, how I did that is I clicked on any one of these dots, I clicked right and clicked add trend line, and then after my trend line came out, I was able to format this right here and put in choose display equation and display r squared. Now, what we're going to do from this point is we're going to show how this works using some formulas. So we can take this, I'm going to decrease the size a little bit so we can still see it, and I'll just move it down here to the bottom. We'll keep it up here. Now in I3, we want to do I3 because we're going to do some stuff. I1, 2, 3 is we're going to use the correlation function in Excel. So this is equals Correl, stands for correlation, equals C-O-R-R-E-L, and it's asking us for 2 arrays. Now we can go back and have named these columns. We could have named column D, square foot, and we call them E rent. But in this case, we're just going to leave it right here. And we're going to do the same way. Our square foot column right here. Shift command down. That's our array 1, which is D2 to D41. And we'll do comma. And our array 2 will be E2, shift command down to E41. And these arrays have to be the same. So if we've messed up a little bit, it'll let us know. Had we named those, we could have just used named ranges and named this column square foot and this one rent. And then our named ranges, we could have just did equals Correl, parentheses, square foot, comma, rent, if that had been our named ranges, and hit enter. And we see this 839225. And we'll put out here, this is correlation. Okay, that's our correlation. Increase that a little bit. And now watch this. This is R squared. So R, the caret, and 2 for squared. I want you guys to actually do this. So we've added our trend line. So create a scatter plot, add a trend line, the equation, and the R squared to the scatter plot. Now calculate the correlation between square footage and rent using the Correl function. So R squared is equal to our correlation squared, which is our shift 6. So it's the caret above the 6, that's our square. And we're just squaring this, so 2. So you've done this on a previous assignment. So we're just squaring it. And that is 7.043. And if you notice right down here, it's R equals 0.7043. So we did this correctly. We have the right information. Now, correlation lets you know how closely they align. Your R squared is the statistical value that represents the portion that is explained by that. So as an example, when we go and look at this in rent can be explained 70% of the time based on square footage. So your R squared of a 1 means it's perfectly correlated, or a -1 means it's perfectly negative correlated. So if you remember in the video you watched on the scatter plots, you can see that this is very highly coordinated. The points are going up and to the right. And so the correlation is 83. So it's getting very close to 1. And you can explain it 70% of the time of the price of monthly rent based on square footage. Now, what's unique is in correlation, it does not matter what the X or Y value. And just because something is correlated doesn't mean it's causation. Where in causation, you cannot change this. We cannot change rent and say this is your square footage. We could with one, but what we're going to do later on, we can't. So the value represents the fraction of the variation that can be explained. Okay, and so with it almost 80% correlation or 80 correlation, it's a very high value that one variable can explain to another. So out of this, our R squared is 70.43% of the variation in rent can be explained by the square footage. So we do have 29.57% out there that isn't explained by square footage. It could be, is it remodeled, its location, its furnishings. And we'll see this a little bit later on, but we're going to actually then bring in bedrooms, bathroom, and things like that. So we have our formula here, and let's write out our formula. So our formula here is y equals mx plus b. So y equals mx plus b is our formula. So let's actually write this down. So we are trying to predict rent. Rent equals, okay, our mx, our m, which is our slope, okay, is 0.552 cents times what the square footage is. Okay, and then, and I keep misspelling footage. Okay, and then we add that to our 512.98. So what is that 512.98? You know, that's our intercept. It's our constant. It's also can be considered our fixed cost. So no matter what rent is on size, the minimum cost is 512.98. So that is our fixed cost in this case, or our base cost. And so that is our equation. So let's go ahead and build a little table. Right now, I want us to build this table. This is rent. So in H9, we'll put in rent. Our slope is next, but our slope is price per square foot. That is our slope. And then we have our square footage. And then we have our base rate, our fixed cost, which is our intercept. So this could be base rate slash fixed cost. This is our intercept. And we can go and format this a little bit. I'm just going up here between each of the columns and formatting that. And so our predictor is rent. Okay, so our slope, which is our square foot cost, is we got this 0.552. So our slope is 0.552. That is our slope. And we can make that a $sign. Our square footage in this case, we can just type in 800 square feet as an example. And our base rate is this 512.98. 512.98 is our square foot. And so if we wanted to know our rent on an 800 square foot apartment, it would be equals our 800. So our 800 times our 55 plus our 512 and return. Okay. So we could figure this out on others. So if I wanted to copy this down, I'm just going to copy that down and copy this down. Okay. I'll copy our equation down too. Okay. And now the reason why I'm getting 512.98 here is that's my constant. So I have no square footage. So if I wanted 1,000 square feet, or if it was 1,200 square feet, we can now predict our rent. An 800 square foot apartment in Ann Arbor within 6 blocks of University of Michigan can go for $954. 1,000 square foot should go for just over $1,000. 1,200 square feet, almost $1,175. So my formula on that again, let me pull this up, is, I'll delete that out. My formula was equals, okay, parentheses, my square foot price, my price per square foot, times my number of square foot, and then I have to add that to, so I close my parentheses there, and then I have to add that to my fixed cost and hit return. And so there's the formula. So we can see how this line here would work. Now I'm going to show you some stuff right here. I don't want you to do anything here. I just want you to watch what I'm doing right now, because we have this outlier out here. Okay, we see this blue, this outlier way out here. Okay, and I've got it highlighted in yellow here on row 40. Is we have this 4,000 square foot, and it's probably a house instead of an apartment near Ann Arbor, that's renting for $2,200. So we have this outlier. I'm going to show you what happens with that outlier. And so in this case, if you wanted to find out real predictive rents and things like that, you would probably get rid of this outlier. So I'm going to go ahead and delete this. I don't want you to do that. I'm just going to delete it here so you can see what's going on. So I'm going to delete this. You can see that my lines changed. Now my equation hasn't. I have to go in here and delete my equation. But you can see that my line has changed. That outlier's gone. And now if I click on the line and hit Format Trendline and put in a new display equation and a new R squared, you see that my R squared, one is that my square foot per price per square foot went from 55 cents to 87 cents a square foot. My fixed cost changed from $512.98 to $447.21. And then my R squared is I can predict the price with 85% accuracy, or 85% of the effective rent is based on the square footage price. So you can see here how outlier may affect your data. For the purposes of this assignment and what you need to turn in, is you're going to leave that in here. So I'm just back out of all of this and take it back to our original. You will use this equation here. Okay. Now, this is really good because it shows here that we can predict rents. And now just format this a little bit so it's easier to see. Give it a blue, give it some borders, because one of the things we've talked about in all of our stuff is making sure that if somebody sees this, they can see what's going on. And then we can just highlight that. We'll give that a light yellow, so easy to see what's going on. So I can see your inputs. So also easier to grade. Now, and visually for you to show what's going on. So now we've done this using, let me X out of this here. So we've done this number 1 and number 2. And now it says run a regression with square footage as the X variable and rent as the Y variable. So if you've already downloaded your pack, we're going to go here to data. And we'll go to data analysis on the right. And we're going to choose regression. You might have to go and scroll down. We're going to choose regression. Click OK. And now here, let me delete these. Okay. And delete this, because this is how yours would look. Okay, so it's asking you for your Y range. Your Y is your dependent variable. It's what you're trying to predict. So in this case, we're trying to predict rent. So I can go here into rent and go ahead and use from E1 to E41. Put the label in there. You want the label when doing regression. And then my X range, my independent variable, what I'm using to try to predict, this is my square foot. So I'll put my cursor there. I'm going to go from D1 Shift Command down all the way to D41, and these have to line up. So I'm E1 to E41, as you can see there, and I'm D1 to D41. If they don't line up, it won't work. And now I'm going to click my Labels button because I want a new label, or I want it to actually bring in the label, so it'll tell me. And I'll click OK, and what it's going to do is going to ask me where to put it, and put it on a new sheet, and I want this new sheet. Okay, so I have sheet 1 down here, and yours could say sheet 2 or something else. Now go ahead and highlight this. I want you to highlight all of this, and then copy it, Command C or Control, go back to your Ann Arbor rental, and underneath your graph, I want you to go ahead and paste it in right there. Okay, and go a couple down. So I want you to go a couple down, just 1 or 2 down, so easy to see, and Command V and paste it. I'm going to put it over here. Okay, so here's what I want to show you now. So all I did was data analysis. Okay, I chose regression. I put in my Y range, which is my rent range. I put in my X range, which was my square foot range. You can see where it's highlighting here. I chose labels and clicked OK. Now I'm not going to do that again. And now it gave me this information. So multiple R, this 83925, that is my correlation. And this is my R squared, is my percent of value of explanation. So again, it says it out there, but I want us to type it in so we understand. This is my R squared. And we can see this. My 839 is my 839. My 7043, my R squared, 70, there's my R squared. Okay, so I'm just going to highlight those also. And we're not going to go into adjusted R squared in those. But now, here's my intercept. My intercept is my fixed cost. There's my intercept right there, the 512, 512, and it's also on this line. There's my intercept. And it's telling me my square foot price, 555.552 cents. Okay, my 552 cents, and highlight that. And then what I'm going to do right now, and I want us to do, is we'll use that to do another. So my y-intercept, which is my fixed cost, okay, that equals my intercept here, return. Okay, so I have my y-intercept. We'll format this in a minute for my square. We'll format it in a minute for dollars with the sign. My square footage right here. My price per square foot is this 55 cents. Okay, return. Okay, and then we could do our predictive rent. So I'm going to type this in here, predictive rent. Okay, and that's what we're trying to figure out. And I'll format this just a little bit. Okay, so this is what we're trying to figure out, is right here. And let's say it was 1,200 square feet. So there's my 1,200 square feet. I'll take these and make those there. And so for 1,200 square feet equals that times this. So we see that it's $662.46 is based on the square footage. And so my predictive rent is equals my fixed cost, or my intercept, plus what my rent is going to cost me by square footage, my 55 cents. And I'll hit return. And I wanted to show you this. I want to show you there's a difference here. So it says 1175.40, and if I come up here on 1,200 square feet, it says 1175.38, and this says 1175.44. And the reason why is up here in our square footage right here, this is 0.55204.649, and we're multiplying that by 1,200, and it gives me 662.46. Okay, If I do it up here, we're just using 552. Okay, we're just using 55 cents or 55.2 cents or $0.552. And here I'm going out. So if I actually change this to 0.00 or 0.552, sorry, 0.552, you'll see this ends up being the same. The only reason why it's different is this 1200 is being multiplied by this decimal that goes way out. So I'm going to change that back. I just wanted to show you the difference, because if you're looking at it and you're going, I don't have the same information, that's why. So we have this table right here, and I want you to show this table because I want you to understand that multiple R is your correlation. Here's your R squared, which tells you how much you can predict one from the other. 70% of the price of the rent can be predicted on your square footage based on this line with this outlier. Okay, and I hit the wrong button there. And then, so we could figure up a 1,200 square foot apartment is $11.75 and 44 cents. Now, we want to go one step further on this. We actually want to do multiple regression, because we see that while we could predict 70% of it, we know that about approximately just almost 30% is predicted by something else. So we have up here in our data sheet, we have bedrooms, bathrooms, and square footage. So for this last one right here, it says run the regression with rent as the Y variable, but this time add bed, bath, and square footage as your X variables. So this is important on how to set up your tables and your information in Excel to know how to do this, because all of your Y variables, your Y variable can be anywhere, unless you're doing a scatter plot, then they need to be next to your X and Y's. All of your X variables needs to be next to each other. Okay, so if you had bed, bath, rent, and then square footage over here somewhere else, it wouldn't work on there, because the array all has to be together when running a regression analysis for your input variables, for your X variables. So what we're going to do right now is go to data, go to data analysis, regression. Our input range for Y, which is our output, actually I say output, but we're inputting, is still the same. We want to know what rent is. But our X range isn't just the D column, it's B, C, and D. So you can type it in here manually. You can go from B1 to D41. So I can just change that from a D to a B. Okay, from B1 to B41 to D41. And that always doesn't work. But what we want to do is I will go here and click on bedroom, do my shift right, bathroom and square footage, then command shift or control shift down, and so I have my B1 to D41. If you haven't clicked labels, click labels and new worksheet. Okay, and click OK, and I want this in a new worksheet for you. So click OK, and now we have sheet 2. So let's take a look at this. We see that our regression is very much closer to 1, our multiple R. So we went from our other sheet from 83 to 89. So very much on our correlation, very well correlated. Okay. Our predictive values have gone up from 70% to now we could predict the rent with 81%. So this is our R squared. Okay, or our how well we can predict. Okay, and now we have our intercept here, and our intercept has multiple variables, because in regression we can use multiple variables. So we have different multiple variables in regression. So that R squared of the 70 point or the 0.7043 means that the variation in the square footage explains 70.43 of the variation in rent. Okay, it explains The R squared tells you how much of the variation in the Y variable, the outcome, is explained by the X, or the predictor variables. Okay, so that equation, y equals mx plus b, which is our regression equation, is y equals, we have our b, I did our b first, the 512 plus 55 cents, roughly 55 cents for every square foot. So for each additional square foot, we could predict that rent would increase by 55 cents. For every 10 square feet, rent would go up by $5.52. So for every 100 square feet, rent would increase by $55. So if this were a cost equation, cost is quantity times price, or cost of quantity, you have your fixed cost, 512 would be your fixed costs that don't vary, and then your 55 cents is your variable cost, the cost of producing one more unit. So your fixed cost would be rent, not paying for rent we're trying to predict, but rent for the facilities, utilities on a fixed cost if there are fixed cost utilities, salaries, not hourly wages, because hourly wages are variables, but salaries and those type of things would be fixed costs. So let's go back here to sheet number 2, and we want to write our equation. So our equation is rent equals, okay, parentheses, $225.81 times the number of bedrooms. We're going to add that to, because we were at here 225.8. These are costing per bedroom, plus $89.27 times the number of bathrooms. So we see what bathrooms are valued at, plus 21 cents. 0.21, or we can keep it at, well, 2095 is plus 21 cents times the square footage. And then that's plus our fixed cost, our intercept, so $300.41. That is our equation on predicting rent. So let's go ahead and make a chart with that over there. So what we're going to do right here is, this is predictive rent, because we're trying to predict rent. Our next is cost per bedroom. Next is number of bedrooms. And we'll format this in a second. Then we have cost per bathroom. Okay. And then we've got number of bathrooms. Okay. Then we have cost per square foot. Then we have what is our square footage. And then our intercept, which is our fixed cost. Okay. And now we can go ahead and format this a little bit. I'm going between my B and C. I don't want it that far. I'll just bring it back down there. I can do that with between my C and D. And the reason why I couldn't do that there is all of this is on one line. So I just made it too big. And we'll do all of this. Okay. And so my cost per bedroom equals the 225.89. And I'm going to do Command T or function F4, because that's going to be fixed, because as I copy down, I want to point back to the same. Okay, so enter. We don't know number of bedrooms yet. Cost per bathroom, this equals this $89. And I'll do Command T or function F4. Equals there. Command T return. Okay. cost per square foot equals this 21 cents. And I'll do Command T again. Okay, and my intercept equals my 300, Command T. I do that a lot. Command equals there, Command T and enter. I just move my mouse. And then we'll format each of these into accounting dollar. So just accounting, because all of these are accounting. These are all cost. Okay. And let's look at this right here. So it says with the mx plus write the y equals mx plus b equation using all three variables. We did that. That's this equation right here. So all three variables. Okay. Says, and then answer the predictive rent for an apartment that's 1,000 square feet, 2 bedrooms, 1 bathroom. So 2 bedrooms, number of bedrooms 2, number of bathrooms 1, and it said 1,000 square feet. So our equation is, our rent is equals cost per bedroom, so parentheses, cost per bedroom, times number of bedrooms, close my parentheses, then I add that plus, parentheses again, my cost per bathrooms, times the number of bathrooms I have, close the parentheses, then I add that to, and then my parentheses again, my cost per square foot, times my square footage, close the parentheses, and then I got to add that to my fixed cost or intercept. And that's my equation. Okay. So my equation is cost per bedroom times number of bedrooms plus my cost per bathroom times number of bathrooms plus my cost per square foot times square footage plus my intercept. That's the equation. Okay. Right there. And now let's make this a little bit nicer. We'll give it a color. We'll do that. And now I can take this and I can copy it down. And the reason why I want to copy it down, and you'll see that it has the same, because what it did is Excel thought we were increasing these. So you can see that it's trying to predict what we want to do, so it just increased those. But I got my formula in the right place. I have my costing in the right place. And now the question is, over here, is at what, and what is the predictive rent of 900 square feet, 2 bedrooms, 2 bathrooms? So I'll change my square footage to 900. My 2 bathrooms, so it's 2 bathrooms, and it's 2 bedrooms. And what's unique about this, and I'm going to change this because I misspelled square. What's unique about this is, while my square foot went down from 1,000 to 900, my rent went up even though my apartment is smaller. And the reason why is, going from 1 bathroom to 2 bathrooms, my rent increased by $89, but I lost $21 in square foot price. So when I went from 1,000 to 900, that's 100 less. So 100 times 21 cents is $21. So it went down $21, but up $89 because my bathroom, so my rent actually increased. And now you can start predicting rents. So this is where we're at. I want you to go ahead at this point. You'll need to go in and answer the quiz questions. Now, some of the quiz questions are, you're going to have to input different information here. And you're going to have to input different information on this table right here. Either one of these tables that we did. This table down here or this table up here. So on the quiz, again, that's my thumb hitting the button. You'll have to input different information here and on sheet 2 to answer the quiz questions. But go ahead and save this file, answer the quiz questions. You have 2 chances on the quiz. And when you're ready, rename the file with your name on it and upload it in the appropriate section. And good luck and very good job. Thank you very much. And hopefully you can see now how you can start using Excel to do predictive analysis on that, and how powerful regression is. So very good. Thank you very much.